In this video, we're going to be looking at the sum of the first 30 terms. So the sum of the first 30 terms of an arithmetic series, where the Tn is given by, okay, let's push this a little bit down, where Tn is given by, let's see, Tn is 7n minus 5 using the formula. Okay. So they want us to find the sum. So they want us to find Sn, right? Of what? Of a linear pattern. Remember, arithmetic is linear, right? So I have two formulas for the sum of an arithmetic pattern. I'll show you how to use both. The first one, it's Sn equals to n over 2. And then you have 2a plus d. Then you have n minus 1, right? Or you have Sn equals to, I'll show you how both of them works, because sometimes it's better to use the shorter one. Over a plus l. I'll explain this one later. For now, we're familiar with this one. Let's start. So they say the sum of the first 30 terms. So, okay, I know that I'm given that my n, the number of terms that I'm adding is 30. So my n will be 30 for both of them, right? Now I need to find the first term. Remember, a is the first term, which is T1, right? So a is the first term both sides, which is T1. Let's see what it will be. So I'm going to replace this by 1 and that by 1, right? Perfect. So we're basically looking for 7, and then we substitute 1 there, minus 5, which gives us 7 minus 5, which gives us 2. So the first term is 2. And then, ladies and gentlemen, if you are given the Tn formula, the number before the n is your d. But I'll show you how to get the d in simple terms, right? Let's go back. So d for this one is going to be d equals to, remember, this term 2 minus term 1, right? If you see here, to get term 2, we have to substitute 2 there, which is 7, 2 minus 5. And then we need to minus the first term, which is 2. So minus 2. I'm not going to write d for this one because there's no d there. And then d is equals to 14 minus 7, which is 7. Do you see it? But in simple terms, you need to know that the number, the coefficient of n is your d, right, which is 7. If you're not sure, always do T2 minus T1, or you can do T3 minus T2, or T4 minus T3. Okay, perfect. Now, let's come this side. We need to get L. L basically is the last term, is the last position. L is the value of the term in the last position. So in this case, L will be T30. Because we are adding the T terms, it means the last term will be 30, since they said the first 30 terms. So let's see what T30 is. So it's going to be 7 multiplied by 30 minus 5, which gives us 7 into 30, and then minus 5, which gives us 205. Now we're going to substitute this into there, and then those ones there, and see if we get the same answer, right? Please press with me your calculator as we go. So for this one, I'm looking for S30 basically, right? So therefore, I'll just move from here and right here to save my space. Sn, for this one, it will be S30, right? So S30 is the same as 30 over 2 into bracket 2 multiplied by my a, which is 2, plus d, which is 7. And then I have 30, which is my n, minus 1. Then I close the bracket. Let's press that on a calculator and see, ladies and gents, we have 30 over 2. Then you open a bracket, 2 in bracket 2 close, plus 7 in bracket 30 minus 1 close. This gives us 3,105. Now let's substitute into that one. So that one we're going to have S30 is the same as 30 over 2. The first term is 2. The last term is 205. Let's see what does that give us. 30 over 2 into bracket 2 plus 205. I'm sure, ladies and gents, you can confirm with me on your calculators that we are getting the same value, right? Which is 3105. So it's good to know how to use both the formulas. So this one is the SN if you're going to be using D. This one is the SN if you're given the last term, because sometimes they can give you the first term and the last term of the pattern, but they don't give you the common difference. So you are forced to use that one. You see why it's important to know both of them. So ladies and gents, please learn this formula, and that one. You must know both of them. Don't say, I'll pick the first one. I don't want to know a lot of info. No, it doesn't work like that. You need to know both. Thank you very much. Let's go to the next question. The next question, which is the last question, what do they want us to do? They want us to find the sum of this series, right? In this case, they didn't tell us if the series is linear, geometric, or arithmetic. We need to find out by ourselves, right? Firstly, we need to find term 2 minus term 1. Let's see. Term 3 minus term 2. If these two are the same, then I can conclude that it's linear. Or I'll check the ratio. T2 over T1 equals to T3 over T2. If the ratio is the same, I can conclude that it's geometric. Right. So let's see. The second term is minus 3. And then I'm going to have minus negative 5. I don't know what the value will be. Then the term 3 is minus 1, minus negative 3. We can see that, ladies and gents, I'm going to have minus 3 plus 5, which is 2. Here I'm going to have minus 1 plus 3, which is 2. Therefore, this is a linear pattern. Why? Because first constant or common difference, right? Perfect. And in this case, I know the value of the last term. I know the value of the first term. So I can use this formula. Sn equals to n over 2 into bracket a plus the last term. Right. Perfect. But I have a and l. I don't know what n is. So I need to find the formula of the nth term. Ne? Okay. So I'll say, okay, Tn equals to, I'll say but, you can say but, Tn equals to a plus d n minus 1, which is the formula of the general term of a linear or arithmetic pattern. Right. I know that my constant difference is 2, so my d is 2. Then I have Tn equals to, the first term is minus 5, so a is minus 5, plus 2 n minus 1, right? And then if I need to know how many terms are there, I'm going to plug the last term into the Tn and solve for n, right? So the last term is 1, 2, 3, because it's gonna give me the position of the last term. If the position of the last term is 20, it means I'm adding 20 terms. So I need to solve for n. Minus 5 plus 2 n minus 1. And then I'm going to have 1, 2, 3 plus 5, because I'm bringing that side. So it's 1, 2, 8 equals to 2n minus 1. Someone here can multiply in, but I'd rather just divide both sides. So what is 128 divided by 2? That gives us 64 equals to n minus 1. Therefore, we can see that n equals to 65. So it's like I'm adding 65 terms. So I can use this Sn, or you can even use this one. It's your choice. You can use Sn equals to n over 2, 2a plus d, n minus 1. And then you close the bracket. You have your n, which is 65. So you put it there. You have your a, which is minus 5. Then you have your difference, which is 2. And then you have your n, which is 65. Right. But I'm just going to use this one. Therefore, I'm looking for the sum of the first 65 terms, which is 65 over 2. My first term is minus 5. And then my last term is 123. Let me just verify. Yes, my last term was 123. My first term was that. Then I press that on the calculator. So 65 over 2 minus 5 plus 123. That gives us 3835. Please use this formula and see if we get the same answer. And leave a comment that we get the same answer to show me that you got to the end of this video. Thank you very much, ladies and gents. Please keep on studying more, keep on studying hard. Don't forget to like, comment, and share with family and friends. Aluta continua. Tango.